students, today I am going to discuss question number 6 of GATE Physics 2017. Now the question is like this. In the figure given below, the input to the primary of the transformer is a voltage varying sinusoidally with time. The resistor R is connected to the center tap of the secondary. Which one of the following plots represents the voltage across the resistance R as a function of time? So for this given circuit, we are given 4 options. So we have to pick one of the 4 options. Now this given circuit is a full wave rectifier with a capacitor filter. Now if we remove this capacitor, then we know that it is simply a full wave rectifier with 2 diodes, and we have this load resistance R. And we know that for a sinusoidal input, this is how the output of the full wave rectifier looks like. So we have positive halves for all these halves of the input signal. Now it is known that the output of this full wave rectifier, it is not of much use for much of the device applications. Why? The reason is that although we have a DC output over here, this is a time varying DC. So this time varying DC is not that useful for device applications. Because for device applications we need a much flatter DC output. So this is the reason why this output of this full wave rectifier is not that useful for device applications, and therefore this capacitor comes into picture. Now the use of this capacitor stabilizes the output of the full wave rectifier. So this is how the output of the full wave rectifier looks like, and this is how the output of the circuit will look like if I introduce the capacitor in parallel with this load resistance R. Now why does this happen? Why do we obtain this type of a output for this circuit? The reason is we know that a capacitor provides a high resistance for DC components and allows AC components to pass through. Therefore this capacitor will not allow the DC components, and therefore the DC components will pass through this resistance, and that is what we want. We want maximum DC at this output R. Now because of that, what will happen is, when this input is given, when this input signal is given, then at that time the capacitor will charge like this, and for the falling signal, the capacitor will discharge like this. But now when it tries to fall down to 0, but by that time it encounters the current from the second diode. So the current from the second diode will then charge the capacitor like this. So it is not able to discharge fully, because by that time it is trying to discharge, it encounters the current from the second diode, which charges the capacitor again, and therefore this pattern is obtained. So here also it will charge like this, and again it will discharge, again it will charge, and again it will discharge. So in this way the pattern will continue, and therefore we can see that we have a much flatter output as compared to the output that we obtained for the full wave rectifier. So this capacitor that we have introduced acts as a filter, that is, it helps in stabilizing the output of this full wave rectifier. So if we look into the options, then we can easily see that this is an AC output, so this is not possible. This is square wave, so this is also not possible. And this is an output of a half wave rectifier, so this is also not the possible solution. So the only option that will left out is this option A. So this will be the given output for this circuit. Hence the correct answer to this question is option A. Now for information sake, you can also remember that if we remove this diode, then this simply becomes a half wave rectifier with a capacitor filter. So this is a full wave rectifier with capacitor filter, and this is a half wave rectifier with capacitor filter having only one diode. And this is the output of the full wave rectifier with capacitor filter, and the output of this half wave rectifier with capacitor filter will look like this. So we can see that the capacitor discharging time in this case is increased as compared to this case. So here the capacitor discharging time is small, here it is large. Why? Because here there is output available for the negative half of the AC input, but here in the half wave case there is no output available, and therefore the capacitor discharges and it encounters the output at the third half, therefore it will start charging again, and therefore this is the output of this half wave rectifier with capacitor filter, and this is the output of the full wave rectifier with capacitor filter. So that's all. Thank you.